in this video, we will cover about Python function. Up until now, this is until week 2, right? We have been working with an individual Python files, okay? And inside these Python files, you have some codes that the objective is try to solve some specific problems. But actually, we didn't do this, but actually suppose in week 3, you should develop some file that contain instructions like assignment, some loops, and some conditionals, okay? But we will discuss this, I think, either in this Wednesday or Friday. What I'm trying to say is all of this approach is basically works well only for a smaller task. But as your project getting bigger and bigger, right? Managing all of your code inside a single file can quickly become burdensome or overwhelming. Okay, so imagine you need to use a same set of for loop in several parts of your code. And let's say after maybe during a certain days, right, you decide to modify this for loop. Okay, so what happens is you have to track every instances of your code where the for loop is being used. This can be a very tedious and error-prone activity. This is where Python functions can help us. Okay, so functions basically it will allow us to organize our code much more better, and it can help us make our code much more easier to manage, much more easier to understand, and much more easier to reuse. Remember, okay, so always remember, a good programming is not just about writing lines of code, but it is about adding much more functionality. So it is about what your program can do, but not how long code is. So by writing a code in a function, this will make your code much more efficient and much more accessible to the other, and even for yourself if you want to revise your code in the future. So as you can see down here, functions allow you to encapsulate code into a reusable chunk of code. So instead of duplicating the for loop everywhere, for example, you can define it once inside a functions and call that functions wherever it is needed. Functions help you to add more feature into your program without necessarily adding more lines of code. Apart from class, which we will discuss in week 6 and 7, so the concepts of functions is fundamental to achieve both the decompositions and abstractions. These are two crucial terms that you will hear a lot about. So the first idea is abstractions. Okay, so what does abstractions mean? It means that we only highlight what is relevant. When we do coding, so we end up writing a long, complex piece of code, but within all these complexities, right, there are often just a few sections that are really relevant or that the user needs to understand. This situations is similar to when we are using a projector. Okay, so as a user, you don't need to know every tiny detail about how the projectors works internally. Okay, but we only interact on the use of the projector via a simplified interface. Okay, so for example, we can operate the projector maybe only just using a simple switch button. But we, as a user, we don't need to know every details that is happening inside this box here. Abstractions is about simplifying complex realities. This basically we only highlight what is essential, but at the same time we are actually hiding the less relevant details. This concept of abstractions, it basically allow the programmer to focus on what the code is doing rather than how it is done. As per our projector example just now, all the complexity of the projector's internal mechanisms, like for example the engineering, all the secretary, so on and so forth, all of these are hidden away. And then the second concept is decompositions. Okay, so decomposition is the process of breaking down a complex problem or systems into a smaller, more manageable part. For examples, right? We may want to create a large image on a wall, like for example, okay, so we want to create a large image on the wall. So usually we can only do this by using multiple projector. So in this setup, each projector is responsible for a segment of the overall image, and every projector receives its own specific input, and the projector will project part of this input as an image onto the wall. Okay, so collectively all of this output, right, enable us to view a large image on the wall. So this is the idea of decomposition. So you take the same project, feed it different input, it does the same exact thing behind the scenes, right? But in the end, it will produce a different output for each of these different input. Okay, so these different devices are going to work together to achieve the same common goal. Okay, so basically that is the idea of decomposition. So similarly, in software development, the software engineer also tend to do the same things. Okay, so where a large task is broken down into a smaller, more manageable pieces. Each set of the code will be responsible for certain tasks. Each task will have its own code that tackle the task independently. Okay, so this is similar to how each projector handle each of the segment of the image. But despite working on separate paths, the goal remain, which is to achieve a common outcome. So in our projector example, we want to create a one unified large image. So we want to apply these two concepts, abstraction and decompositions, into programming. So in Python, we can achieve both of the abstraction and decompositions via functions and class. Okay, so like I mentioned earlier on, a function is a set of code that we can use over and over again. Okay, so we may supply our function with an input values, and then the function will perform some specific operations, and after that, after it complete the operations, it will return some output values. Okay, so functions are really as useful if you have an operations that need to be done repeatedly. For example, calculations. For calculations, right, we are basically using the same formula, but the only difference is we are feeding different value for the parameters. Let's say we have a function that what it simply do is, so let's say here we have a function, right? So what we do, so we pass a value, and then these functions will accept this value, and then behind the scene the function will do some calculations or some magics, and after that the functions will return some output values. Okay, so take for example here, if we have a functions that we call as square. Okay, so this function is responsible for squaring any integer that we feed into these functions. So in this case, if we supply the functions square with an integer 4, so it will do the calculations and it will return the value of 16. So according to Python documentations, the function definition should have so it should start with the keyword of def, the ef, and then followed by the function name, and then you have this bracket here, and then here we will write the param. So param is the input parameter. Okay, so this is in this line 2 here is where all the logic of the functions. So in this case here, if we invoke this function print text, right? So what it will do, basically it will feed this hello UMS inside here, and then the compiler will print the text or string, and this is what will be output in your screen. Okay, hello UMS. So like I mentioned, when writing a functions, you must begins with the def keywords. So basically this will signal to the Python that hey Python, you are about to define a functions here. Okay, so immediately following this def keyword here, you will have the function's name. Okay, and after this function's name, you will have this parenthesis, and inside this parenthesis, you will list all the parameter or all the arguments. Okay, so basically these are the inputs that your functions will work with. So once you define the function's name and the parameter, then you can write all the function logic inside the function's body. Okay, this body is made up from, as you can see here, is made up from several statements. And one thing to note, okay, so this is a common mistake among beginner. So one thing to note, you have to indent this statement here. Okay, so usually we will use a 4 space indentations. If you're not doing this, then of course our Python will give you an error. Once we have our functions, then we can invoke our function as in this line 3 here. Okay, and after we invoke it, then Python will do all the necessary and it will print the text 0 here. So sometimes we may want to create a functions that accept multiple parameters. Okay, so you only can you may do some slight modifications. So inside this parenthesis, right? So you list the parameter, all the parameters, but you separate them using this comma. Okay, so here we have param 0, comma, param 1, comma, so on and so forth. Okay, so basically each of the parameter or object is separated by comma. The order of the parameter definition is critical. Okay, so when you call or when you invoke these functions, right, you must pass the argument, okay, the actual value to the function in the same order as the parameters that we define here. Okay, so this ensures that each parameter receive the intended output. So for example, okay, so in this example, we supply the value for base value and exponent value. Okay, so when invoking the functions calculate power, we also supply the argument base value and exponent value similar. Okay, so basically the position should be the same. And sometimes when we write a functions, right, sometimes we need the functions to give us some return value. Okay, the way we do this is by using the return statement here. Okay, so think of it as a way of the function saying, okay, so I'm done do all the necessary calculations, and now I want to give you the return values. Okay, so once the compiler see this return value here, the functions will stop whatever it is doing and it will send the value back to wherever, to the line that is invoking the functions. Okay, so this makes sure that our program can continue with the informations that we receive from here for subsequent analysis or subsequent computations. Okay, so this is an example with a return value. Okay, so here we have a function with a name of area, and this function is responsible to do calculations about area lah. Okay, so these functions require only one input, which are the circle's radius, and after completing the calculations, then this function will return the calculated area. Okay, so once it receives the calculated area, and then we can print the value of the calculated circle area. So sometimes we might need our functions to return more than one value. Okay, so to do this, we can use the same return statement. However, here we can put the return value, and here we separated it with a comma. Okay, so here we write return value, comma, and value. Okay, so what happened behind the scene is basically Python will pack these two variables here as a tuple. Okay, and here you can unpack these two value here, and you can use it individually in your programs. Okay, so as of course this feature is quite handy if you need a multiple piece of informations from your functions. Okay, so for example here, this function calculates circle properties. It will return two values, which are area and circumference. Okay, so here we receive the value of circle area and circle circumference, and then we print individually each of these variable. You may pause this video and see what is the issue with this code snippet.